I have this triangle I need to build based on this given information. And side A is going to be opposite side alpha, side B is going to be opposite angle beta, sorry, angle alpha there, and so on. So first thing I'm going to do is draw my side, a side at the bottom here, and then measure alpha from that. And you can either guess at that, or if you happen to have a protractor, which is pretty cheap at your local mart, use that. And then I'm also going to use a compass, but if you don't have a compass, a piece of paper will work as a compass. I'll show you how. So first we need to draw a line to work off of. I know there's already a line there, but it's nice to see it in pencil. It's my brain focus on what I'm doing. All right, and then if you didn't have a protractor to measure 39, what I would do, and you didn't have a ruler, just get a piece of paper out, find that 45-degree angle through all those diagonals on those squares there, and then just tweak it down to you think, yeah, that's about 35 right there. All right, so I'm just going to guess at 35 right there. Just made a little mark up here. We'll see if I get it right. So I often just guess because I don't happen to have one of these on me all the time. Okay, so line up your protractor. Find 30, 40, 35 would be right here. And it looks like I overestimated with that piece of paper. And then draw your line in. Best of your ability. So here's my line. And I guess 35 is a little more up here. So I was a little bit off. Oh well. All right, so that's my alpha at 35 degrees. And side A has to be over here. Side B can either be up here or down there, doesn't matter. I'm going to pick it at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that's the end right there of my side B. So this is side B down here. Now, if somebody said, let's let A be 7, then 7 would be about here, and a circle of radius 7 is not going to hit that line up there. So that would be an impossible scenario for a triangle. But 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 3 from 12. That would be a circle starting here. And then I'm going to mark that circle up, and that's going to tell me where, from this point right here, a side of length 9 is going to hit that side. And you can either do that with a piece of paper by just measuring off 9 on the paper. So if this is 0 here, I'm going to say 9 is right there. And then I just hold that point at that where the 12 is, and I just keep moving that, rotating it until I hit the line above. So I can see right here about is where that would hit. So that would be one point on my triangle. But check this out. If I keep rotating, I'm going to use my compass to do this here. From here, let's get that lined up. Right, almost. That's close enough. My compass hits there where I said it would, but if I keep rotating, it also hits up here at the top, almost off the screen. Let's extend this line a little bit. This is one of those ambiguous triangles. There's 2 possible triangles with this information. So up here is another intersection point right there. So I have 2 possible triangles with a 35-degree angle here, side length 12 here at the bottom. So I either have this big triangle here, right, this whole big triangle where angle beta here is an acute angle, or I have this smaller triangle down here where this angle right here, beta, is an obtuse angle. Now, if we use the law of sines to solve with these 3 pieces right here, right, what we're going to have is that the sine of beta over side B, 12, equals the sine of alpha, 35 degrees over side 9A. And if we solve for B, the arc sine only knows about acute angles. It's going to give us this one, not that one. This other obtuse one is going to be 180 minus, 180 degrees minus the acute angle from the law of sines, because the arc sine only knows about those acute angles. It only knows about angles between negative 90, 90, negative pi over 2 and pi over 2. Let's see. And I used my calculator to calculate that. Oops. So here I'm finding the arc sine of 12 times the sine of 35 degrees divided by 9. I made sure it was in degree mode. And I'm getting almost 50 degrees. Let's check that out. So is this angle up here about 50 degrees in my picture? Oh, that's pretty damn close. Look at that. 50 degrees. I did pretty good. Cool. Nice. So I like drawing these. Do you have to have a protractor? No, but it's pretty damn cool, I think, and they're not very expensive. So have fun, do good math. I'll see you later.